Everybody, welcome to EMEA Working Group Paper Modular Construction webinar. Today we will be discussing the question of the modular construction and risk connected with this. My name is Marina Zyuganova. I'm head of engineering, property and specialty underwriting in Renaissance Insurance Group, and together with my co-presenter Mamoon Alyah, who is the Managing Director and Principal Engineer of CEERISK, we will be dive deep into the risks connected with the modular construction. To start with, I would like to take this opportunity and say great thanks to the whole working group paper team, to all the people who contributed to the working group paper. So Benjamin, Yekaterina, Giacomo, Hervé, Hans, Neil, Kate and Mamoon, thanks very much for the great job you've done. In our working group paper, we covered several very important sections. First is modular construction itself, its definition, how it is applied, the processes, the deployment, and so on. The next section is main risks attributable to modular construction, and here we have split them into four stages: design, fabrication, transportation, and on-site. And we will later on show why. Next section is concerning survey and risk management and PML assessment, and Mamoon will dive deep into this section with some additional examples and comments. Then, of course, we touched underwriting considerations because we need to not only find and evaluate the risks, but also to consider them while drafting the policy coverage. Also, the coverage for delay in startup is very often used in this type of project, in this type of construction, especially because this is a very good instrument for the developers to cover their financial risks. And we, of course, have some claims examples, lesson learned from claims, and the working group conclusions and recommendations. So to start with the definitions, we found that it's not so simple and obvious, and there are different types of modular construction which are widely used. So the main types are volumetric, as you can see here on the screen. These are three-dimensional modules. The second one is panels, two-dimensional modules. Components is the mixture of the two above, and pods are often used with the volumetric construction. What is also very important here is that there are some some advantages that modular construction has as in comparison with the traditional construction. There are some of these advantages. First of all, it's the ease and speed of construction. Modular construction is up to 50% more fast than the traditional one. Modular construction exploits economies of scale. Of course, there is an increased product liability due to regulated quality assurance systems. There are lower risk of health, safety, and security related issues. And of course, together with the speed of construction comes cost savings. Possible savings could be up to 20%. And the last but not the least, modular construction seems to be more environmentally friendly. So this type of construction generates less garbage and waste. But as it is usually in our life, some advantages come with some disadvantages, because these advantages give some additional risks to the type of construction itself, and we will show it later on. It is also very important to compare main phases in modular construction and in traditional construction. As we can see, in modular, phases consequently come one after another. So first we need to have the design made, then we are fabricating the modules, then we transport them to the construction site, and at the end we install them on site. We can't start the construction works without the fabrication and transportation. And as we will see, the risks are split into these 4 stages in different parts. For example, for traditional construction, it is not a big problem when something is damaged during the construction on site. Sometimes, and in most cases, could be repaired. This is not the equipment, but the construction works. With the modular construction, it's not so simple. In most cases, we need to make the changes or even refabricate the modules, which leads to the rather long period of restoring the damaged property. We shall cover all these stages, and we shall speak about the risks for all of these stages, and Mamoon will in detail tell us about the risk assessment on each of these stages. So the first stage is design stage, and here the following is very important. As we use modular construction, we need more time for design, and the design should be more detailed. So both macro and micro phase are essential, and even a small mistake or small defect could lead to the severe losses, and we will see this even in some claims examples. So the following should be considered while assessing the risks. As one of the particularities of the modular construction is the connection between the modules and the foundation on site, the tolerances for connections are very important. Second point is 5 P's. Prior planning prevents poor performance. So prior planning is the key to avoid all design errors. And the third issue is project schedule. As we discussed on the previous slide, project schedule could be rather tight, and this aggravates the risk of a lot of DSU coverage, but also for material damage. Second phase, manufacturing. Again, there is a difference between traditional construction and modular construction. In modular, a lot of risks are on this stage. From one side, the risks of external events like nut cut are a little bit lower, because the modules are constructed within the factory premises, and so they're not too prone to weather conditions, etc. But it is very important to assess whether this coverage extension is included in the policy or not, and if yes, what covers what risks are covered. So the coverage extension could include flex and not cut and even SRCC risks. Also, very important issue, and I think it's worth to be mentioned that cyber risks are rather high here in comparison again with the traditional construction, because a lot of BIM software is used and SCADA systems are in place for the supervision of the models during the fabrication. Here again, I think Mamoon will talk about this a little bit in details, but we found that the following should be checked while we are assessing the risks. There should be a good coordination between the manufacturer and the contractors, because even a small mistake in manufacturing can lead then to the huge loss. Then quality plan is crucial, and all involved parties have to be have to understand when and how inspections will take place in the factory. Also, the risks of cracks is rather high, because some components are rather often lifted, and this should also lead to losses. Next stage, transportation stage. In traditional construction, we do not put so much attention on this stage because not all the components are transported. Most of them are built on site, but here this is the huge part of the risk lies in this stage. Firstly, because of the transportation itself, so some of the questions of the transport security is relevant. The distance between the factory and the construction site is also very important, and and the road conditions also. The method of transportation is very important, and also sometimes, as we are talking about here, not only on engineering risk but also on risk connected with cargo. The storage is rather important, where the modules are stored when they are transported from the factory to the site. Also, what should be underlined that sometimes a physical loss could occur during its storage or transportation, and if it is not identified immediately, and in most cases it is not identified, the modules are installed on site, and in most cases, again, while repairing the damage, we need to go back to the factory to change and to reinstate the damage, and then to transport the module back to the construction site. And the last stage, which is the same for the traditional construction and for the modular construction, is on-site works. So here we can see that the risks are more or less traditional. They are fire, natural catastrophes, mismatch between models and foundations, and errors in lifting operation. If to speak a little bit more in details on these risks, we can say that there is again a difference between modular and traditional construction. In respect of fire, in modules we do use more combustible materials like polyurethane, sometimes plywood, sometimes timber. So all of these are combustible. The second issue, which is important for the fire risk, is compartmentation. And with modules, there could be some problem, because modules are sometimes not very close one to another. There are slight gaps between them, but for the fire it's quite enough, so the fire can spread very quickly through these gaps, and this could lead to a rather big loss. Also, a very important thing is the nut cut. Here, two things should be noted. The first one is that as modular construction is quite a young sector of the construction industry, there is no adequate testing experience for earthquake. The second thing is that especially in high-rise modular buildings, the wind load are rather high, so if the models are not quite close one to another in the first floor, the problems can arrive somewhere on the high levels. And again, in modular construction, one of the main operations is lifting. So it is very important that all the participants should be certified and tested in accordance with the applicable regulations. Again, it's coming back to fire losses and fire risks. Not all the regulations, the country regulations are adopted to the for the modular construction, and not all of them are underlying the importance of the absence of gaps between the models, and not all of them are underlining this risk. I think with this we can stop here, and I will hand over to Mamoon, who will dive deep into the details of risk and risk assessment.
Thank you, Marina. Appreciate it. Hello, everyone. We're going to just go a little bit deeper into the risk assessment and look at what a risk engineer should be aware of and looking at. I think Marina did an excellent job outlining all the risks that we have to worry about and all the risks that we have to be cognizant of and be on the look for. What I'm going to try to do is dig a little bit deeper on some of the risks. Now, as risk engineers, we all have quite a bit of information or quite a bit of a system of how we analyze and assess a risk in a construction project or related to a building and so on. The problem here, and this is something that Marina mentioned earlier, in construction, in modular construction, it's really not one type of risk, because we're not dealing with a single type of a project or a single location for that project. And it's not only one type or the other of the hazards that we have to deal with. There's quite a bit of a variation and differences in the hazards, in location and in the type of hazards. In fact, we have to be putting on quite a bit of different hats all the time. We need to look at the design or the risks involved in the design, as well as those in the manufacturing, in the transportation, and even in the construction on site. And that's what I'm going to try to explore a little bit and emphasize or talk about. Like any risk assessment process, we need to identify the risk factors, the hazards that will affect our property or our construction. What we're worried about really is the project cost, the duration of the project, as well as all the actually property damage that can actually be sustained at one part or during the construction of these modular buildings. We need to determine these risk factors and determine their weighing, basically rate them based on their severity, based on their frequency and likelihood of happening. And then we come back and basically say, okay, we need to worry about this and worry about that. It is very important to also be evaluating the measures and controls in place to make sure, or to actually examine and look at whether we are able to manage or the insured is going to be able to manage this risk or not. So I'll just put the, so basically, if we come into the construction or the modular construction, like I said, we need to identify the hazards, look at the mitigation measures, look at the loss prevention that comes with the project management, and is it coming with, is it inherent, is it built in, that loss prevention, has it, or is it going to be carrying through all the way from top management all the way up to laborers, and in all different locations. There should be a written risk register which is updated regularly to identify the critical objectives of the project and to keep everyone aware of the conditions and aware of the situation and the risks. And there has to be an incorporation of the BIM into managing the risk. There are a lot of different risks, general risks. I found this in one of the papers and research that we were doing. It just gives you a quick explanation and summary of all these risks. But we're going to delve in and get in detail into a couple of those risks as we go through them, starting with the design. Really, with the design stage, what we really need to worry about is a couple of things. One, are we, as we're building these modules, are we going to be able to fit them all together? And are they all going to work together when it's time to put them together on site? Now, we are really constructing them off-site at a manufacturing plant, but we have to design them in such a way that when we put them all together, they will fit together and they will be tolerant and they will actually be able to stand in place. There are a couple of different things in there that we have to examine, we have to look at during the risk assessment process. Are the contractors aware of all these problems? Not just the contractors who are building and fabricating it, but also the contractors who are bringing in some equipment to put in. It's much easier, actually, to come in and fit the electric, the plumbing, the mechanical, the fire alarm, the firefighting, and all of that. But are they aware that when it all has to be put together, it has to all work together? Do they know? How do they know? Who is managing that process, the coordination, the planning, and the management of that design process? The 5 Ps that Marina mentioned earlier, prior planning prevents poor performance. I'm reminded with another saying, a failure to plan is really a plan for failure. This is extremely important and extremely true when we're talking about modular construction. The reason is, where it's built is different than where it's going to be all assembled and put together. It has to all be planned properly and taken into place. Now, part of the planning process is the actual coordination between all the different parties. And the different parties here are a lot of different parties. You have suppliers, you have subcontractors, you have equipment manufacturers, you have different types of people who have to put that thing together and have to coordinate and communicate together to make sure that it's going to be delivered on time and it's going to be delivered correctly. One of the things that we will come to later on, the fact that because these things are being made, let's say in a serial way, in a multiple different way, a small little design problem or a small little defect in the design or the manufacturing is going to appear across a lot of these modules all together. And the problem is not going to be limited to one location or one area. It's going to be actually widespread throughout the entire construction. Planning, I think one of the things that we have agreed in the paper, and I think we can't emphasize enough, is that planning is really the trick. And as an insurer and as a risk engineer, we need to be able to assess that. Is there enough planning? Is there enough coordination? Are the duties and requirements of all parties carefully defined? Does everybody know what they need to do, when do they need to do it, and how do they need to do it? The role and duties of the designers need to be considered. The different disciplines, it's not just a construction or a structural, it's not just electrical, it's not just mechanical. They all have to be planned accordingly. It has to be very clear on the communication and coordination between them. So when we are assessing the risk or assessing whether the design stage is actually being done or the risks during the design stage, we have to be able to ask questions about or review the documents and the methods of communication between all the different parties, and how do they all work together and coordinate to make sure that problems are dealt with quickly and dealt with effectively. The transportation offloading, this is very, very important. Just like Marina mentioned, under regular construction, you really don't have to worry about transportation because that would be covered by something else. If it's not on site, you don't have to worry about it. In this case, we have to incorporate and coordinate that process as part of the construction, because you have to make sure that these modules are coming to where they need to come in. Now, when we move on to the manufacturing, in the fabrication, we need to worry about the actual regular things in a manufacturing plant. Do they have their fire protection? Do they have their fire alarm? Is the quality of the air being monitored and being taken control? Do they have controls to make sure that the mold formation is prevented? You don't have mold building up during the fabrication process. Are the parts being stored correctly? And then once fabricated, is the ready or the fabricated units or modules, are they being stored properly? Marina mentioned and talked about the cybersecurity and the other general and on-site risk factors. So all these factors, different factors, have to be considered in the fabrication. It is an extension to the actual manufacturing property, risk assessment of the manufacturing property or the manufacturing location, but then you have to consider the impact that would have, all the different risks would have on the actual modules being built. Now, once this is done, there has to be some sort of, during the survey, again, we need to be looking and on the lookout for the coordination level between the manufacturer, the component suppliers. Do they have a simple, easy way to communicate and to coordinate how these component suppliers are providing these components and installing them in the modules? We have to look into the quality assurance plan, because this is very, very important. If the thing is not built correctly, then during transportation we have a higher risk of it failing, and then when we arrive on site we also have a much higher risk of it being damaged or sustaining some problem. So all these different things have to be looked at. Now, what sometimes makes this a little bit challenging is the relevant regulations. So this modular building can be designed in one country, fabricated in a second country, and then put together in a third country. Or if we're talking about, in the case of the United States, it could be in one state with certain regulations and certain rules, and then it has to be transported across state lines to another location. So we have to be really aware of the applicable regulations and how these regulations impact that design and that fabrication process. The risk of cracks is very, very real and very, very serious, because when you have one single site and you are building or constructing a building, very simply you're constructing it there, it's sitting there and it's working and looking, and you can just turn it over and it's done. In this case, you have to build it somewhere else, move it, and then put it together. So there might be quite a bit, or there is quite a bit of a risk for these cracks to actually develop. Now, transportation is a new element or a new risk factor that has to be taken into other risk factors. Many risk factors have to be taken into consideration here. How good are the drivers? Are they licensed or not? What is the temporary, and this is very important, the temporary road that needs to be used to deliver these modules? Sometimes you have to have a different route because they're not going to fit under a bridge, or they're not going to fit in a certain way, or there is a regulation that prevents them from going in a certain road. So you have to look at all these things, and you have to consider, or the transportation company has to have an understanding and consideration of all these different things. Again, I'm going to mention and bring in the regulations. Especially if it is running across interstate, like in the United States or in Europe, from country to country or in other countries, you have to look at all these different rules that would apply to the driver licensing and certification, the vehicle licensing and certification, and the route licensing and certification. So you have to actually, all of that has to be looked at and has to be considered. Not necessarily by the risk assessment or the risk engineer, but the risk engineer needs to ensure that these factors have been considered, have been looked at, and are being planned for with the underlying, with a very strong underlying planned for early on, and a coordination has been put into place. Exposure to cold, heat, moisture during the transportation, and then when they have been transported, when they arrive on site, where are they going to be stored? How are they going to be stored? How are they going to be all put together? Now, during the site assembly, now we're moving into going back into our, I wouldn't say traditional risk factors or construction risk factors. We were going back to a construction site. So we're aware of all the different risk factors on a construction site, all the way from fires into collapse, into natural catastrophes, into all these different things. What I wanted to highlight is the coordination aspect. Are all the major contractors and subcontractors in line to be able to connect these modules together once everything is put together? Then there is the lifting risk. The lifting risk is considerable in this kind of situation. Cranes have to be available. We have to consider the radius of the crane. We have to make sure that these cranes are able to manage and to lift these modules. We have to make sure that these cranes are also certified, tested, and periodically inspected to make sure that they are efficient and in a good condition to operate during that process. Quality inspection, all the way of how and at what intervals during the construction process do these take place. Is the quality inspection done by a competent person, and what is the standard to which that is being done? Is it being done regularly? Is it being done when it's supposed to be done? And how is that process managed? What technologies are there to test the quality of the connections, especially these connections, whether they are services or the construction connections? The quality acceptance method, the standard system, the catalog of building parts and components, the proper testing and certification of the materials and the accessories. Who's doing that? How is it being done? How frequently is being done? Are questions to always, for the risk engineer to always look into and make sure that they are happening. Then the risk engineer needs to really look at the project management process, the assessment. How is all of that being managed? Who's managing it? And how is it being managed? How is it being coordinated? All of these are different factors that have to be considered. So ultimately, really, what we wanted to highlight and what we wanted to bring or have everybody remember is on site there are different cranes. These cranes bring in quite a bit of risk that have to be considered and looked at. Transportation whole units is not a simple, easy process. You're not moving boards of material or brick or cement bags. You're actually moving built-in modules. It is a very complex process. You have to get specific routes in place. You have to get specific certification or licensure in place. The material used in offsite construction sometimes is susceptible to conditions at the manufacturing or at the manufacturing plant. That's why the air quality at that plant is very important and has to be considered, has to be taken into account. And it's easy to foresee the fabrication or manufacture of whole component units abroad, potentially from less regulated territories, and bring it into where you need it. That brings up all these questions related to transit and jurisdictions and the licensure and codes that have to apply. I think it's something that we thought about, that, you know, why build it right here in the country where you want to use it if you can do it in a much cheaper price somewhere else and bring it and ship it over. So that brings in quite a bit of questions and quite a bit. It's done. It's really done in equipment and heavy machines or big machines. Components are being built in a different country according to a different standard and a different regulation, and then brought in and put together. So the same can apply for buildings as well. So surveyors or risk surveyors should be given access to the assembly line. Assembly line here is the fabrication location, to look at things periodically and to make sure that this is being done correctly, because if a mistake is incorporated into the design or the fabrication of the unit, then it becomes a serial mistake, a serial problem that will repeat itself everywhere else. I'll bring it back to Marina to talk about the underwriting considerations right now. Thank you.
Thank you very much, Mamoon. Can you see my screen now?
Yes.
Okay. Wonderful. So, underwriting considerations. As we know, contract works are normally cover suppliers for their on-site activities only. So when we were discussing this, we found that we should underline the following things. The first thing to mention here is the so-called policy interference issues. What we're going to dive a little bit deeper here is the territory of insurance, the insureds themselves, and some clash with the marine coverage. The first point to consider is the definition of the site within the policy. Normally we are covering just the construction site, but as we discussed already, here could be not only one territory covered, not only the construction site where the modules are installed, but also some, rather often the territory of the fabrication, and sometimes some other off-site locations, and even anywhere in connection with the project or anywhere within the country in connection with the project. The second point is to consider is the insureds. Who is the general contractors, or do we have the general contractors? Sometimes we don't. Sometimes the risk is split between the manufacturer, the transportation company, and the company who is installing the modules on site. Sometimes we do have general contractors which have all of these risks to manage. And finally, the clash with marine coverage. Here we should be very careful with the accumulation, because we do have the experience when the could be accumulation between the sum of the engineering coverage and marine coverage. These issues are all very important for two considerations. And the first one is the coverage for defects, which is rather often granted in modern wordings. I mean here the London Engineering Group D5 or LEX 3. And as we know, here it's very important who is insured and what is considered the damage. So that's why the question of the territory of insurance and the insureds are very important. The next issue is with the maintenance cover. So we do know that in maintenance cover we are responsible for the damages which originated from the period of construction. And here it's important how the period of construction is defined. Do we define the period of construction as only the construction on site, or we are including the transportation and manufacturing here? So depending on how this and also the question of the territory of insurance is defined, the results will vary. And as Mamoon mentioned already, the serial losses is very frequent here. Even a small mistake on the stage of design, on the stage of manufacturing or during the transportation will lead not to small loss, but to the rather huge loss, serial loss. And we will show this a little bit later on in describing the claims. Coverage for delay in startup. Modular construction are mostly used in residential building, but of course they are used also in industrial buildings, but in less quantities. And as usual, the delay in startup cover is being purchased together with the material damage because the developers are interested in such a coverage. And as modular construction have some particularities, their influence on the assessment of risk and delay in startup are rather high. So what we found that we need to analyze a very carefully time schedule to avoid narrow time frame, and we discussed already that using modular construction gives us the economy in time, and in this case the advantage of the modular construction become a disadvantage in assessing delay in startup. Then the second issue, we should define critical modules and path activities and analyze lead time, the time of delivery of modules to the site with the maximum indemnity period and with the time excess, time exclusion. Of course, we need to assess whether delays, some kind of inaccurate quantities or late deliveries. And it's very important to understand the extent to which modules can be repaired on site. Because again, if we will found that there is a problem with the module and we need to go back to the factory, it is obvious that the loss could be rather huge. Also, the following should be considered. As usual, the suppliers and manufacturers extension should be carefully analyzed and assessed here, because it takes a huge part of the risk. There could be some delays due to redesigning and adding or improving the insured property, and this should be also assessed during the risk assessment. And as I said, when analyzing the risk, we need to understand what is the period when we can order the model on the factory, and it can be transported on the site. And now we'll try to illustrate this with the case studies and claims. The first claim here is the hotel. The hotel was built in 2013 from modules constructed in a factory in Northern Ireland, and the main material of the modules was combustible. It was a structural insulated panels, combustible polyurethane insulation held between the two sheets of oriented strand board, which is made from the wood flakes. And here, to go back to Mamoon's explanation about the compartmentation, here was the problem that the models were not too close together. There was a gap between them, and the fire spread within this gap. So what we are seeing here, what lessons we can learn from here, is the lack of adequate compartmentation as the first reason. The second, the absence of fireproof inner walls, and the wide usage of combustible material, which caused the spreading of fire. And again, as all the building was made from modules, this mistake was rather huge, because it was kind of a serial loss. The second example here is the hotel facade. It was formed out of prefabricated brick elements that were glued together in a factory and hang up from the top of the site. There was something around 60 prefabricated elements, and when 1/3 of this quantity was already installed, there were cracks on the lining, and there were also some different possibilities how to manage this. But in the end of the day, it was decided to change this lining with the traditional bricks. It took some time to dismantle this lining and to put the bricks, and also the insulation was damaged because of the weather conditions. So again, we can see here that a small error led to a severe loss. And the third claim is non-residential claim. It's the project, the construction of onshore liquefied natural gas plant in Arctic climatic conditions. And here approximately 240 modules were used. They were fabricated, of course, not in these climatic conditions. And the models were covered with the BFP and CSP, I mean the passive fire protection and cryogenic spill protection here. And the problem was that in winter period, the cracking of fireproofing coating and cryogenic spill protection was observed. And investigation showed that cracking occurred due to inherent properties of material used for coating under the extreme weather conditions. So the reason was that the coating was not properly tested in Arctic climate conditions. So the contractor had to change this coating, and again we can see that this small problem lead to several rather huge loss. So we found that several risks are essential, and there are particularities of the modular construction, and I will once again summarize them here. The possibility of defects and serial losses in modular construction is rather high. We also found that the cyber and transportation risk here is higher than in traditional construction. Also, we found that there could be a huge problem when we found a mismatch between the modules and foundations. Again, high exposure to winds and heavy rains and not enough testing experience of earthquake exposure. Problem of fire risk with the wide usage of combustible material and the lack of compartmentation. And also a high DSU exposure due to the very short period of manufacturing and construction. So we found that the following could be done to mitigate risk, but of course every project should be carefully analyzed and assessed case by case. These are just very I would say very common things to be to think about. First, the design should be set and agreed before the project commencement, and all the participants, all the key participants, the contractors, the manufacturers, even the transport company should be in early stage in the process, and this is very important. Second thing is the coordination between these parties. So we need to understand and we need to evaluate how they do coordinate with each other and what should be improved, if something could be improved, and what are the plan in case of if something will go wrong. The close monitoring and control of the risk is essential, especially if we are granting the DSU coverage. And again, we need to have a very experienced project team that has the ability to coordinate and manage the various project phases. So with this, I think we are finishing our presentation, and we are ready to answer any questions, or we can discuss any questions or suggestions or comments. If you have some questions, please write them down in the chat, or you can also use your microphone and we can discuss it all together.
Marina, I see a question from Ridica. He says, can you explain why cyber is a higher risk?
I will try, and I will also ask Mamoon to help me here. We are talking about here that cyber is very important issue to consider, because a lot of modules, all the modules are constructed on the site, and in most cases it is not made manually, but in most cases with the usage of computers, robots, etc. Later on, I think in a month, we will have very important, very interesting working group paper on 3D construction. I think we can also discuss the question there. But the main reason here is that there is a lot of using the BIM and SCADA systems, and sometimes some of this usage can cause some electronic computer risk. So if something will go wrong, the defect will be in the module, and this will lead to serial loss.
Yeah, I think that's exactly it. Because these units are not fabricated at a construction site, they're fabricated as a manufacturing plant, and the manufacturing plant has a lot of automated systems, robotics, and other things that can easily be hacked into or can easily be, not easily, but they can be hacked into or are vulnerable to the risk of cyber hacking and cybersecurity. That's the main reason.
Okay, can I move on to another question? It says, what has been the cause of the fire in lesson 1? In the lesson 1 that you showed, what has been the cause of the fire?
I'm not really sure we know what the exact cause is. We used it to highlight the spread, the risk of fire spread. Because of the compartmentation or lack thereof, the small fire which occurred in one specific location have spread rapidly and aggressively across all the different modules. I'm not really sure. I can't remember, Marina, if you do. I can't remember if there was a mention of what was the actual cause of the fire.
Same thing here. I do not remember exactly. I just can imagine that sometimes maybe it could be short circuit or something like that. But yes, you're right. We use this mainly to show the spread of fire.
The risk of the spread.
Okay, have another question. Is there already a kind of international ISO norm or similar?
I'm not sure about the ISO norm or an international standard. There are quite a bit of organizations that are preparing documents and preparing some sort of guidelines and documents on these, and they vary from country to country and from location to location. I haven't run across anything international that is something that would apply across the entire world, but you can bring in bits and pieces from every place. That's one thing. The other thing also is, it is a standard for what? That's the problem with these modular construction. So you might have, I think the NFPA is developing some documents for the fire safety on modular construction. You get another organization developing something related. I think the construction engineers or the structural engineers, Association of Structural Engineers in the United States is developing something related to the putting them together or the construction. I think there are some other regulations related to seismic protection and so on. But one single norm or standard, we haven't run across a specific one, I don't think.
Yeah.
There is Stephanie. Should I carry on with the message with the questions?
I think yes. Yeah.
Okay. So there is a question regarding modular construction, specifically addressed in the usual design codes. Like I said, each country is developing some of it, but again, you want to look at what is it that you're looking for. Is it the fire safety? Is it the construction code, and so on? I don't think we really spend too much time digging into the availability of these. I do think that we all agreed or came to the conclusion that this is evolving as it goes. So it hasn't been yet fully developed to have these standards that you can actually refer to a reference in a policy or anywhere specific. So this is, I think this is something for you, Marina. It's what is the most widespread use of modular construction?
We also haven't dig very deeply in this question, but we can say that modular construction is more widely used in residential construction. Housing. But of course, with the example of plant, with the example of LNG plant, we can see that it's also applicable in industrial risks. Exactly, especially if these risks are have the territory somewhere where there is no so many people, and we need again some modules for living.
Yeah, residential is by far, I think, the most widespread use, but I have seen it in developments here in the UK, actually, where the development is made of houses and made of buildings, brick and mortar, and then there is the community center right in the center of the development, or the school built of modular construction. So it has been deployed in different locations, but based on what we read, I think the housing is the most widespread use for it.
Yeah.
What are currently the technical limitations, size, dimensions of the modules, building height? I don't think we have any specific limitations or specific numbers on that.
Yeah, we don't have.
I think it's evolving and it's continuing. There are records of even taller and taller and taller buildings being built. I've read an article or a study about some of these in China, built to like really high. I'm not going to say a number because I don't know exactly what is the number, but it keeps expanding and it keeps going up actually every year from the year before. So compared to a traditional construction, you will deal with a shorter construction period, so you will have reasonably smaller rate. Would you consider a higher rating than traditional way of construction? That's an underwriting question for you, Marina.
Thank you, but I think due to our rules as an EMEA, we do not have any, we cannot have a right
Pricing
to
discussion.
Pricing. So we can just say that the most important thing here is to split the risks on these 4 stages and assess whether the risks are higher than in traditional construction all over. And this could give us some thoughts how it should be rated.
Yeah. I think, Stephanie, I think this is going to be posted on the library. There was a question regarding whether it is going to be posted on the library, EMEA library. Eventually it will, yes.
Yes.
What are your thoughts on scale mockups, VA increased use of 3D modeling? I don't think I have any. Marina, do you have any thoughts on the scale mockups versus increased use of 3D modeling?
Maybe I can comment on here that we do use more 3D modeling in modular construction and the scales in traditional one. And as you said during the presentation, the difference here is how we measure the cracks. So when we can see the cracks and when we construct something on site, we can somehow manage this. And if we have a model already and we have a crack, then it could be once again a serial problem. So I'm not sure we can give too many details here. I don't think that the 3D modeling can help in any case. So maybe some instruments coming from the traditional construction should be also used.
Yeah, and I think the same comment applies to the next question regarding the SCADA systems, the use of the SCADA systems to mitigate manufacturing risks. Yeah, automation in general. And the use of SCADA and the other use of programmable logic and so on is always going to help mitigate manufacturing risk. The question starts by also saying that apart from being a cyber risk, so that was going to be my second comment. Yes, of course it's going to help, but we have to also be aware that it opens the door to more and more cyber risk or cyber hacking into any of these systems. But the three, I mean, the automation process and automating the manufacturing process is always going to help make these products and modules a lot more safer and a lot more easier, or mitigate the risks.
Mm-hmm. And also a small comment from my side. When we were describing the third loss with the LNG plant, it is more in detail described in the paper. There was used in the case of LNG, several types of coating was used. Some coating was made in fabric, and some coating was made manually. And an experience showed that in case with the fabric coating, there were more problems than with case with the those which were made by hands. So again, it could be different from one project to another.
Yeah. Yep. And I think the last question is, do you think about multidisciplinary groups of companies that provide end-to-end work, design, manufacturing, and on-site construction? I'm not aware of any, but I think there might be some that would actually provide it all the way from the conception, from inception of the design, all the way up to turnkey. I think they do have those, and they are into place, but I'm not thinking of any specific ones. Do you have any specific ones in mind?
In my experience, I think it's rather widely used in in construction, in apartment, not apartment, but small timber buildings construction. So
Yeah.
it's constructed on site, then transported, then just constructed on site. But
Sure.
there we do not see too many risks except for fire.
Yeah.
So no cyber, I think.
Yeah. Excellent. Stephanie, I think these are all the questions that we have in the chat.
As far as I can see, yes. James Aubrey just made one more comment. There are a few in the UK, and I think that's pertaining to the question that you've just answered. Something's just popped in. Oh, when will the working group paper be released? That's a question for you guys.
To be honest, we have already finished it, but we are polishing it from the point of view of editing. So I think in 1 week we can upload it to the EMEA website.
Okay, and another question. What is the typical DLP/ERP for these projects?
DLP and ELP?
ERP. DLP, ERP.
I think we need to know a little bit more.
Liability period. Sorry, defect liability period. Okay. And extended reporting period. That's an underwriting.
Yeah. To be honest, we haven't discussed it when we are working on the paper, but I think the rule here is similar like in other project, 2, maybe 3 years.
Okay.
But I think the origin of the question was maybe when the problem occurs in most cases. I think the answer here is that the problem occurs during the construction, or maybe a little bit after the construction, during the first year. So not as in IDI coverage within the 10 years or so, I think a little bit earlier.
Okay.
That seems to be the end of, every time I say the end of the question, we get another one, which is fine because we have time. What is the lifetime of normal buildings.
You mean normal modular buildings, modular construction buildings, I think.
Yeah, really good. I don't know, do you want to, modular, he says,
Yeah,
modular
modular.
building.
I'm not really sure that it's going to be any different than normal construction, which will depend primarily on the construction material, on the weather conditions, on many different factors. So if you're looking for a life expectancy, I don't think you're going to get a specific life expectancy that is or applies to everybody and everything everywhere. It's going to be different in many different locations. That's one thought I have. The other thought is, I don't think this technology has been around long enough for us to actually have all that historical data to establish that question. But I don't see why it would be any different than other building, provided that it's constructed properly. Your thoughts, Marina?
Yeah, I completely agree. Maybe I have a thought that maybe construction material, we use the combustible material like timber or plywood. Of course, this influence a lot on the period when the construction could be used. But generally, yes, I think no big difference between the traditional construction and modular. And I do agree with the problem that we do not have enough statistics. So maybe in a 50 years or so, we can answer this question a little bit other way.
Yep. Okay.
No more questions at the moment.
Okay, so I think we have answered everything. And thanks very much for joining us today. Thank you, Mamoon, for joining me for these presentations. And thanks a lot for help to our working group teams. And we will be happy to see you once again on another EMEA webinar. The next one will be just on Monday.
Yes.
Super.
Thanks
Many
very
thanks
much.
for all your work.
Thank you.